Okay, we are going to look at lesson 54, which talks about, they call it the substitution axiom, and really we're going to solve equations by using something called substitution. I actually like these problems. So for example, if we have two equations that have two different variables, an x and a y. Let's say we have 2x minus y equals 1, and we have x equals negative 3y plus 11. And they want you to solve it by using substitution. Solving meaning finding the value of x and y. What does x equal and what does y equal? Well, if we had a problem, let's look on this blue paper. If it was just an equation with one variable, if I said, what does 2 plus x equals 18? If I told you to solve for x here, you could easily see that x had to be 16, because 16 is the only number that would make this equation correct. Now I want you to solve for x and y, though. If we only had one equation, if we just had 2x minus y equals 1, that would not be enough information to know what x was and what y is, because we have two variables. But if they give us another equation where x also equals negative 3y plus 11, then we can figure it out. And the way we can do that is we need to combine these two equations. And we're going to substitute one for the other. Here's what I mean by that. In this first problem, this means that we're multiplying x 2 times, and then we're subtracting y, and that equals 1. Well, like in this equation, when you have an equation with only one variable, with only one letter, you can solve it. You can figure out what it is. So what we're going to try to do is to get an equation with just one variable, with either just x's or just y's, because then we will be able to solve it. And once we solve for one of the letters, then we can use that information to solve for the other one. So if we see that x equals this, we're going to put this in parentheses. That's a very important step. If you don't keep those two together, when you start subtracting and doing other stuff to this, you can get the signs all mixed up if you don't put it into parentheses. So we're going to start by putting that into parentheses. This equation here says that x equals this thing. So what we can do is anywhere we see x in this equation, instead of x, we can put in this because they're equal. So here we're multiplying 2 times x. And since x is equal to negative 3y plus 11, we could also say 2 times this, because we're going to substitute, that's where the substitution comes in, this in for x. So we're going to do 2 times, instead of x, we're going to put this in. And that's why I want you to put it in parentheses, because that must stay together. This whole expression, negative 3y plus 11, that whole thing equals x. So when we're multiplying it by 2, we need to multiply 2 by the whole thing, not just this first part, not just the negative 3y, and not just the 11, but the whole thing. So keep it in parentheses. So we substituted this in for x. Now we're going to go ahead and subtract y, and that equals 1. So basically, we just took this part of the equation and stuck it in the first one. Now we can solve this because we only have y's, and if we only have one letter, one variable, then we can solve the equation. So due to the distributive property, which would be negative 6y, because 2 times negative 3, and then we're going to multiply that 2 times 11. Keep watching the signs. And now we're going to subtract y, and that equals 1. Now we have negative 6y minus y, which gives us a negative 7y. We're going to subtract 22 from both sides, which gives us 1 minus 22 is negative 21. Now we're going to divide each side by negative 7. That gives us just y. And negative 21 divided by negative 7 is 3. So y equals 3. So we went ahead and solved. We have what y equals. How do we figure out what x equals? Wow, now that we know that y equals 3, we can put the 3 in for either one of these equations. We're going to put it in this top one. So if we put 3 in for y, that gives us 2x minus 3 equals 1. Again, we have an equation that has only one variable, one letter, so now we can solve it. We add 3 to each side, which gives us 2x equals 4. X, then dividing each side by 2, x would equal 2. So now we have y equals 3 and x equals 2. We can write the solution like that, but you can also write it, remember we talked about ordered pairs last time we were in class? An ordered pair, we graphed them on a graph. And the ordered pair is always in this formation. It always has x first and then y. So we could write either y equals 3 and x equals 2, or we could write it as an ordered pair. The x is 2 and the y is 3. So if they say use substitution in these two equations to find out what x and y equals, you can write the answer as y equals 3, x equals 2, or you could simply write it in this ordered pair, which would be 2 and 3. So let's try another one just to make sure that you have it. We're going to try using substitution. Use substitution to solve this set of equations. They're sometimes called simultaneous equations because they are 2 or more that the x and the y has the same value for both equations simultaneously. All right, so we are going to do negative x minus 2y equals 4 and y equals negative 3x plus 8. How do we solve this? Well, we're going to do it by substitution. We can see that we have y equals this. Remember, first thing you want to do is to put that in parentheses. That's such an important step. Put a little star by that. I don't want you to forget that, because what will happen is you'll end up separating these two terms, the negative 3x and the 8, and you will get the wrong answer. So put it in parentheses because y equals this whole thing. We're going to take, in this first equation, we're going to substitute this part of the equation in for the y. So we're going to rewrite it as negative x minus, the signs are very important, 2 times y. Well, y equals this whole thing. So we're going to rewrite it in here, in parentheses, and then that equals 4. Now we're in business. We can do this because we only have x's, so we can solve it. Be very careful with the signs. We're going to keep this as negative x minus 2. We are going to do the distributive property. We have negative 2 times negative 3x, which is positive 6x. We have negative 2 times positive 8, which is negative 16. And that equals 4. This right here is one of the places where a lot of students make mistakes. They forget to watch these signs and multiply carefully negative 2 times negative 3x and negative 2 times 8. So watch that. If you get the answer wrong when you do your corrections, which I hope you all are doing, remember those are the most important part of our whole semester is the corrections. If you get something wrong when you look at the corrections, go back and see if you missed a sign, missed changing the signs. Okay, negative x plus 5x, negative x plus 6x equals 5x. We're going to, 5x minus 16 equals 4. Adding 16 to each side gives us x equals 20. All right, we know what x is. X does not equal 20. I forgot to divide that each by 5. This is 5x equals 20. We're going to divide each of those by 5, which means that x equals 4. That sounds better. Okay, x equals 4. If we know that x equals 4, then we can figure out what y is by putting 4 in for x. So we're going to put 4 in right here. So 4, that would become, instead of negative x, it becomes negative 4 minus 2y equals 4. If we add 2y to each side, we get negative 4 equals 4 plus 2y. Now we're going to subtract 4 from each side, which gives us negative 8 equals 2y. And now we're going to divide each side by 2, which gives us negative 4 equals y. So now we have the answers that we need. We wanted to solve for x and y. We could write it as x equals 4 and y equals negative 4, or we can use that ordered pair system again. Remember, the ordered pair is x, comma y. So x would be 4 and y would be negative 4. So the answer in the back of your book might look like this, or it might look like that, 4 and negative 4. So that's how you solve simultaneous equations. You can go ahead and try them in your homework. If you get confused, just go take a real quick look back at this video, and it will help you go step by step. But watch the signs and put those things in parentheses, and I think you'll be all set. Okay, the last thing for this week is lesson 55, which is complex fractions. I actually really like these problems too. These ones are simple if you remember something else that we did on our math tips a long time ago. All right. Sometimes we come across fractions that are a little more complex. For example, if we have the fraction a divided by b in the numerator and all of that over c, and it says, it'll say in your book to simplify that. Well, how do we simplify that? This is the best way to remember that. If we remember that this sign right here in a fraction, like in the fraction 1 over 4, that sign right there means divided by. Remember, we wrote that in our math tips a long time ago. But if we remember that, then this becomes easy. This means a over b divided by c. And then to simplify that, remember, when you divide by a fraction, it's the same as multiplying by its reciprocal. Do you remember that? So a over b divided by c is the same as multiplying by the reciprocal of c. C is the same as c over 1. The reciprocal just changes the numerator and the denominator around. So it becomes a over b times 1 over c. That is, a times 1 is a, and b times c is bc. So this complex fraction, a over b all over c, when simplified, equals a over b times c. So this would be your answer. That's how you simplify them. Really easy if you remember that this line in a fraction means divided by. So we're going to try another one of these complex fractions. We're going to try 1 over c all over 1 over b. These ones are pretty simple. Just remember, we have, that means 1 over c divided by 1 over b, which is the same as dividing by 1 over b is the same as multiplying by the reciprocal of 1 over b, which is b over 1. 1 times b is b, c times 1 is c. So, if you need to simplify this complex fraction, that's the same as b over c. Simple, right? Let's try one more and we'll be done with the videos for this week. Let's do a over x all over b times a over a plus x. Okay. How do we simplify this? When you see this addition thing, just like we did in the previous lesson, put it in parentheses. That's going to save you a lot of trouble. All right, remember, this means divided by. So this means a over x divided by b over, in parentheses, a plus x. How do we solve that? You know how to do this. A over x multiplied by this reciprocal, which we put the numerator and the denominator on opposite sides. Now we can solve it. We can multiply a times a plus x, which equals this, all over x times b. And I think we can go ahead and leave it. Yeah, we don't have to multiply this out as a distributive property. We can just leave it like that. So that's your answer. That's this fraction becomes this. I think that's it for this week. Good luck. And please contact me if something is confusing. And we do have our final when we come back next Monday. So make sure you're studying for that. Good luck and God bless you.